sections, but today we are going to continue on to the next section, which is expanding and condensing logarithmic expressions. So can we expand them? Can we condense them? So looking at this problem, we are graphing this by hand without the aid of the calculator. Maybe. There we go. Just Alright, well, we'll just do it over here for now. So using those three properties of logs, the first property says a log of any base of the number 1 is always equal to? 0. The second property says the log of any base of that same number is equal to? 1. Those are the two properties that are easy to use.
Yeah.
The third property,
Oh yeah.
the third property involves exponents. If I take the log of any base and then the number has an exponent, it's equal to whatever the exponent is. The last couple of problems of your homework in the book used that property and just got you to evaluate using the property. But that is the harder one to think of graphically. We need new markers in here. Yeah. He has them all over here. Look at this.
Oh my God.
Mr. Cummings. All right. Not sure why this little guy is here. And yeah, there we go. So when you're choosing numbers for x, the first number you should choose is the number 1. Every single time, pick the number 1, because when I have the value of 1 and I plug it in, I would have 2 times the log base 4 of 1. This part here is equal to 0. So I'm really taking 2 times 0, which is 0. Maybe. So I would pick 1 because the log of any base of 1 is always 0. And then you're doubling it. You're multiplying the answer by 2, but it's still 0. The second number I want to choose should be the same as the base. So if my base is 4, the second number I want to choose would be a 4. Because then I'm taking 2 times the log base 4 of 4, which is really 2 times 1. I should have moved these lines down below so I have room for my work. So I have a value of y at 0, and now I have a value for y at 2. I want you to choose 2 other numbers, and that's based off of the exponent property. So if I have an x here, and my base is a 4, I need to think of a number that would make that as an exponent. So 4 to the negative 1 would be a good number to choose. I could choose 4 squared. It just gets a little bigger. So if I want my number to be 4 to the negative 1 because it has an exponent, what's the actual x value that you're using, Hannah? 1/4. And again, the reason I'm choosing 4 to the negative 1 is because then it fits that exponent property. So if I can write the number as an exponent, then it fits the third property. So this says I have 2 times the log base 4 of 4 to the negative 1. So I'm going to write it as an exponent when I apply it into the values. And then my exponent is the actual answer, because the base and the value are the same, so it's equal to the exponent. And then I'm multiplying that by 2. So I'm taking 2 times negative 1, which is negative 2. Now 4 squared probably isn't a really good number to use, because it's kind of big. But we'll see how it works. So 4 squared is actually the number 16, so that's 16 is my x, but I'm choosing 16 because I can rewrite it as 4 squared. So I would have 2. The log base 4 of 4 squared. here, which is really taking 2 times what? 2. Yeah, whatever the exponent is. That's how that simplifies. And 2 times 2 is 4. So now I have 4 y values for the 4 x values that I chose. So my first x value was 1 to match with property 1. And that gives me the intercept. My second x value was 4, and we got out a 2. And then I have a fourth, because that was 4 to the negative 1. And we have a negative 2. And then finally we have the 16 and a positive 4. So that's going to be over here somewhere. Make sure you continue to curve your graph. There's an asymptote in this graph, and that's one of the questions over here that I now have a whole bunch of writing on. So the first question is what is the domain, which maybe we should ask the asymptote question first. But Carrie, what do you have for the domain?
0 to positive infinity.
So 0 to positive infinity. Carrie, the range is negative infinity to positive infinity. The range will always be negative infinity to positive infinity. It will never change. So always negative infinity to positive infinity for the range. And then Carrie, the vertical asymptote is at, don't forget to draw that in. That's part of your graph. Your graph skims along the vertical asymptote. So once you find that asymptote, make sure you're skimming, creating the graph to continue along that asymptote. So I'm going to talk about number 3 from the homework. Definitely number 4, and then if we want to look at one of the 2 in the back, we can. But if you look at your homework, if I don't see work, I have no clue how you're getting those numbers, besides looking up everything later. You've got to have some kind of work for these problems. So numbers that appear magically make me feel a little uneasy about how you're getting those numbers. So there has to be some type of work. It's like, how are you creating them? I even have work for mine. And I'm not saying I'm smarter than you, but I'm older and I know more. Doesn't mean I'm smarter, I just know more because I'm older. You at some point will probably know more than me, some of you, which is fine. But I'm really good at math, and I know a lot about math, and I still have to do a little bit of work for this. So the number 3 says negative log base 3, and then in parentheses, x plus 2. We have to try and use these 3 properties when we're picking x values. Hopefully this works a little better. So the first value that I need is a number 1. But I can't just pick a 1, because if I make x 1, then I have 3, and then it applies to a different property. So I need to look in the parentheses and ask myself, what number plus 2 would give me a 1 so I can use the first property? Colin, what number plus 2 would give me a 1? Say it again. A negative 1. So I'm going to plug a negative 1 in. Because when I do that, I have negative 1 plus 2. So this is my little bit of work here. So this makes negative log base 3 of 1. Maybe I'll put it over here. So I plug in the number 1. Now it looks exactly like my property, and it's supposed to be equal to 0, because the log base 3 of 1, the log of any base of 1 is equal to 0. When I multiply that by a negative, it still gives me the value of 0. So I'm picking a number so that whatever's in my parentheses becomes the number 1. So then for my second x value, I want the base and the value here to be the same. So my base is a 3. Lauren, what number plus 2 would make it a 3? 1. So now I have a positive 1. So negative log base 3 of 1 plus 2 now says that I have the negative log base 3 of 3. And it applies to property number 2. This part here is positive 1, and then I need to multiply it by the negative value outside. Okay, the third property is the hard one, because I need to think it has to become an exponent. So try and think of, like, what number do you want it to be? So if I have a base of 3, And I need to write it as an exponent. What number would I try and make, like, wanting to create in that parentheses, Hannah?
9.
Right, so we want to make 9 because 3 squared is 9. So you need to ask yourself what number plus 2 makes 9, because that number is the number you're choosing for x. My goal is to get 9, but I have to make 9. So Hannah, what number plus 2 makes 9? 7. So we're picking a 7 for x because when I plug that in, 7 plus 2, I now have 9, which is really 3 squared. And the reason you want to have that as an exponent is because that's the third property. Because then whatever my exponent is would be the answer. So the exponent is a 2. Multiplying that by the negative makes negative 2. So I want you to have 1/3 value because I want you to try and get a fraction in there. So my other option, instead of having 3 squared, would be having 3 to the negative 1. I want you to have a negative exponent so that we get like a fraction. So negative 3 to the negative 1 is really 1/3. That's the number we're trying to get. I need this in parentheses to be equal to 1/3. So what number plus 2 equals 1/3, Carrie? Yeah, negative 5/3. So I need some number, increasing it by 2 to get to 1/3. Well, 2 is really 6/3. So if I have a negative 5/3 and 6/3, then I have that 1/3 value. And yet the reason I'm using that is because I have to apply the exponent. The exponent property. So now I have negative log base 3 of negative 5/3 plus 2, which is 1/3 or 3 to the negative 1. So carry, this y value becomes 1 because it's a negative 1, and then I multiply it by a negative, so it's a positive 1. So now I have 4 y values to graph with my 4x values. And I know I didn't give out graph paper yesterday. You can always just make yourself a little graph by placing a couple of little tick marks on the graph. So I have a value at negative 1, positive 1, and then 1, negative 1, 7, negative 2. I need a couple extra tick marks here. 6, 7. And then my last value is at negative 5/3 and positive 1. So negative 5/3 and positive 1. So I can see, having that last point, that it starts to curve. And that's why I want you to have a value that's a fraction so you can see where that curve happens. Where's the asymptote in number 3? Printed? Yeah, at negative 2. This graph is shifting left 2. Remember, whenever there are numbers with x, it's shifting to the left. So the graph is shifting left 2. Questions? So if you flip the page over, let's look at one on the other side. And we look at number 5. So thinking about the same process, we have the log base 3. All of these were a base 3, so you're kind of using the same base value, same 3. So the first value, I want to choose a number that creates the 1. So I have 1 minus something. So 1 minus what will make 1? Colin? Yeah, 1 minus 0. So my first x would be 0. Because if I plug it in, I then have the log base 3 of 1. And Colin, the log base 3 of 1 is 0. So here's my y, there's my x. So property number 1 is done. The second property, I need the base and the value to be the same. So my base is 3. So I need to pick a number in the parentheses that makes it 3. What number could I use in the parentheses that's going to make that value 3? So 1 minus what makes 3? Emma? 2. So log base 3 of 1 minus negative 2. And Emma, that y value is 1. So I'm choosing x, but you gotta think about it a little bit. What x values are good so that I can apply it to the property? But the goal is for you to be able to have a function or an expression where it's applying directly to the property. So then my third one is where I have to think about exponents. So 3 squared, or 3 to the negative 1. Our goal is to get a 9, or the goal is to make it 1/3 when I plug it into the log. So 1 minus what number makes 9? Garrett, 1 minus what number makes 9? Negative 8. So then we have the log base 3 of 1 minus negative 8. That gives me 9. 1 plus 8 is 9. 9 is 3 squared. And based off of the property, it's equal to 2, because whatever the exponent is would be my y value. And then the last one, if I want to get this to be a fraction of 1/3. 1 minus what makes 1/3, Brenton? 2/3. So log base 3 of 1 minus 2/3 is really 3 to the negative 1. There we go. So that makes negative 1. So you kind of have to think about what number you're trying to create. How can I apply that into the parentheses to get that value? And then graph it. And again, yeah, you didn't have graph paper, or maybe you had some extra graph paper lying around. Gonna have to restart it, I think. So if I make a little graph, eventually, the first number we chose was 0. And there was also a y value at 0. So I have a point at 0, 0. My second one is at negative 2 and up to 1. My third one is at negative 8 and up to 2. And then my last one is at 2/3 and down at negative 1. So if it ever graphs for me, there it goes. Again, getting that fraction kind of shows you where it starts to curve. That's why the fraction value is important. This also has an asymptote. Its asymptote is at positive 1. Don't forget the asymptote. Draw that asymptote in my graphs. It's going to log. Questions? Hopefully that helps a little bit, trying to think about the thought process. So today, I think there are 4 or 5 examples that we're going to look at. It's a really tiny page of notes. It's just a front page. And it's on continuing with properties, but properties of logs, expanding or condensing them. So if you look in your packet at page 13, yeah, you didn't like it? I think you'll see that it makes a little more sense going over it a second time. Each time you go over it, you review it. Hopefully it solidifies the concept a little more. And the first problem we were talking about yesterday, that change of base formula. So when we were plugging it in the calculator, you can plug in anything with a base of 10. Ooh, jeez. So if you look at your calculator, there's a little change of base formula. So yesterday on the side of your calculator, we said you can use the log button on the side of your calculator when the base is 10. You can use the natural log button on the side of the calculator when you're talking about e. However, what happens when the base changes and it's no longer a 10 or it's no longer a natural log? And that is called the change of base formula. So I can rewrite this expression, the log base 4 of 30, in order to evaluate it or to figure out the number, the answer, by taking the log of the big number divided by the log of the base. Change of base formula. So if I look at my problem here, how would I rewrite the log base 4 of 30 to try and use the change of base formula, Brendan?
Log of 30 divided by log of 30.
Right. So you're taking the log of 30 divided by the log of 4. Now, in the calculator, there are 2 different ways you can do this. Here's my calculator. So the one way would be literally to hit the log button and do the log of 30, and then divided by the log of 4. And then you get me. It says 3 decimal places, 2.453. However, there's another option in your calculator. Does anybody know where the change of base formula is in the calculator, Josh?
Isn't it math?
So he said math and A.
Yeah.
And if you go down to math and A, it says log base. And it actually has the formula already in the calculator for you. So some of the calculators have it, my old school one doesn't. Brenton's doesn't have it either. But if you do have it and you hit enter, it converts it and it looks exactly like a log with a base. So I would put the base of 4 where the base is supposed to go, and then my value is 30. So in the calculator people, the Texas Instrument people, already created the formula and plugged it in the calculator for us. I can still hit enter and I get the same number. So it just depends on what calculator you have and how you're going to be able to work through the problem. But that's what the calculator is doing. It's really taking the log of 30 divided by the log of 4. Questions? So change of base. So we can graph anything or use any function in the calculator with log. The base can be anything. We just have to kind of use the application or the function in the calculator to get it to do that. So looking at the second type of example, we have these properties of logs that it sounds like you think you remember from last year. So the first property is very similar to exponents. So when I'm multiplying 2 logs together, I can expand them into separate logs by using addition. Same thing with exponents. When I'm multiplying, I can condense them by using addition, by adding the exponents. So they're kind of like opposite properties because they're inverses of each other. The second one, if I have division, I can expand it into 2 separate pieces by using subtraction. And again, the exponents work the same way. If I'm dividing, I condense them by subtracting the exponents. The last property is the power property. And the power property says you take that exponent and you bump it in front. And then it becomes n times the log of a of base a of u. Again, the exponents, when I have a power to a power, I still multiply those exponents together. Works the same way with natural log as it does with the common log. So the example underneath wants you to verify, which is a nice way of saying prove or show that the 2 sides are equal to each other. And if you start with the left side, so we have negative natural log of 1/2. How can we show that that really is the natural log of -2? Or positive 2, not -2. So how can we use the properties to verify or show that the left side really is equal to the natural log of 2? So what's one thing that we could do? So this -1 right here, she said we can move and make it an exponent. So I have the natural log of 1/2. We're moving the -1 and making it an exponent. That's property number 3. So those properties go back and forth. So I have a number being multiplied, I can move it back in exponential form. And then if you actually do the math, what is 1/2 to the -1? 2. Verifying just means transform one side or use a little bit of algebra or a property to make it equal the other side. So by using that third property and taking the value we're multiplying by into exponential form and then actually doing 1/2 to the -1. 1/2 to the -1 is really 2. The fraction becomes a whole number. Questions? The other 2 sets of examples on here, as I said, little short day, want us either to expand or condense. Squish it together so that it becomes 1 log. So if you look at the 2 examples, we're pretty much trying to get them to look like each other. So the first set of examples, I want to expand, which means write it as a sum of or difference of multiple logs. So how do you expand something? We have 10 log base 10 of 5x cubed y. How do I expand that column?
She just, so each one is like adding to each other.
Right. So each thing that's being multiplied now expands into addition. So log 10 of 5. Log 10 x cubed. Log 10 y. So each piece becomes multiplication. Dylan, what else? You don't have to write the 10. No. If it's any other number, yes. But the 10 is the common log that you don't have to write. Dylan, what else could we do? So it's not quite expanded.
You can put the exponent in front.
Right. So the last part would be then to take the exponent and move it in front of only the piece that has that exponent. And again, you don't have to write the 10. The 10 is the common log. So if you don't write it, that's fine. Because it's assumed, which assuming isn't generally good to do, but it is assumed to be there. So I'll cheat there and I won't write the base. And that's it. It's expanded. Each piece is written separately. So letter B says the natural log, it doesn't matter if we have a log or a natural log, properties are the same. Square root of 3x minus 5 and then divide it by 7. So Emma Humphrey, what do you think you would do there? Okay, so division means separate it, expand it into subtraction. The whole square root stays together. What else can we do to continue to expand it? We're not done. Okay?
Throw 1/2 in front of natural log.
Why 1/2?
Because you're taking the square root.
Yeah, so when you're taking the square root, that really is an exponent of 1/2. So 3x minus 5 was underneath the square root. Really, that means 3x minus 5 is to the 1/2 power. So that goes in front of the natural log, and then we have the natural log. This goes in parentheses. It's grouped together. Both of those are contained with the natural log. One part isn't separate. And then the natural log of 7. But I'm not separating this any further because it was underneath one square root. It's still grouped together as the quantity with this first natural log. So 1/2 natural log of 3x minus 5, parentheses, and then minus the natural log of 7. Again, that's expanding. So the last 2 problems ask you to condense, which means I want to squish them together back into a single log. So my answers should look like the ones above. So Garrett, how would you start this problem?
Distribute the numbers in front of the logs.
Yeah, so pull them. Again, that x plus 1 is a quantity, it's now cubed. No, you don't have to FOIL that out. It's actually more simplified to be kept as a quantity cubed. And then Garrett, what else could we do to condense it?
1/2 exponent can become a square root.
So 1/2 exponent becomes a square root, and the plus sign turns into,
Would just turn into negative sign, or does it?
how would I condense those two together?
Oh, multiplication.
Multiplication, there you go. So behind that, in parentheses, x plus 1 cubed. So we have the square root of x, because that was a 1/2, times x plus 1. That's it. It's now condensed into a single log. So the last one, we have 2 natural log of x plus 2 minus the natural log of x. So Hannah, what happens there?
First, you would put the 2 back to the exponent.
Again, in parentheses, don't lose the parentheses. And then Hannah,
Since it's subtraction, you would go division, so ln, and then x plus 2 squared over x.
right. You only have one natural log. I don't keep ln divided by ln. So my goal is to condense it into one. The natural log goes outside of the fraction. The terms that follow are what creates the fraction. That's it. Question? So tomorrow will be a review of the first 3 sections. Your homework, expanding and condensing, trying to apply some properties. Anybody interested in doing 61 or 83? Colin, 61, Perry, 83?